Okay, so today we're going to look at normal distribution and inverse normals. I'd like you to start off by reading this question, trying to draw a sketch of the problem on a normal distribution curve, and then seeing what we can have a go at the question. So try and turn this question into a sketch of a normal distribution curve. I'll give you a few minutes to do that. So what we got first is we're going to be measuring x, which is the weight grams of cauliflowers. We're told that x is normally distributed, and the parameters for that is 821 for the mean and 40 squared for the variance. So we can sketch the problem now. Looks like this. This is at 821. We're then told that the heaviest 8% of cauliflowers are classified as oversized. So this area here is 8%. That weight is K. That weight is K. So that's what we know so far. We can't find that value directly. Is that a right tail or a left tail? This is a right tail. So we want the probability that x, which is the weight of cauliflowers, we want the probability that a randomly selected cauliflower has its weight greater than k. So if it's greater than k, that probability will be 8%. Now, in order to do this, there's a tool on the calculator that lets us do this, but it only calculates left tails. This is the big trick on this one, is it never calculates right tails. How will we find the size of the right tail? So this is the left tail. The calculator won't find this for us. We want the calculator to find this. What's this green area going to be? 92%. Why is it 92%? The other one's 8%. Why is that true though?
Because it's all equal to 1.
The whole area adds up to 1. The whole area adds up to 100%. So we want the complementary probability. So the probability that x is less than k is equal to 1 minus 0.08, which is the probability that x is less than k is equal to 0.92. Okay, so k equals, we just put this into the calculator. So very easy. On the calculator, we want menu, probability, distributions. Now we want number 3. So on the calculator, for the probability distributions, we never use 1. We use 2 and 3. We use A and B for the binomials. So we want the inverse normal distribution. We say that the error, we can type the error in like this if we want. We can type it in as 1 minus 0.8. It'll do the calculation for us. Our mean is 821, and our standard deviation is 40. We get 877. This tells us that k is 877. With these inverse normal problems, at this point, compare that value to your diagram. Is 877 in the right place?
Could you go back to the calculator?
Is 877 in the right place? Well, here's 821, so we're expecting a value which is more than one standard deviation. One standard deviation would be 861, and this seems to be in the right place. What you're going to catch is if you forget the left tail, right tail thing. It's very common. You're going to do that at some point.
How do you know when something's a left tail and something's a right tail? Only when you draw it?
Only when you draw it or when you read and interpret from the question. We know that the heaviest 8% would be at the top end. We know that we want it to be bigger than the heaviest 8%, not less than the heaviest 8%. So it all comes from the wording in the question, which can be interpreted to the diagram. And then to catch you making mistakes, because you will make this mistake, I do as well. I find the diagram helps me. So if you forget to do the complementary, watch how it comes out. You'll get 0.8. We have our mean of 821 and our standard deviation of 40. And we're going to get 764. Now look, 764 is down here. It's calculating the smallest 8%, and that usually helps you catch it from the diagram. This number is less than that one. It's in the wrong place, so it's clearly not that one. We want 877. In fact, what you should see is the relationship between these two values is that they are both the same distance from 821, because the distances are going to be the same. This is a symmetrical diagram. Let me show you that calculation. So if I take this number here, and I subtract 821, I'm going to get 56 units off. If I take this number here and I subtract 821, I'm going to get 56 the other way. Notice the symmetry of the diagram and the symmetry of the situation. You can use this symmetry to solve some of the harder problems where you're not given numbers, you're just given letters, and then you use this symmetrical ideas and they'll help you with your problem solving. All right, so we have a bit more time today than I did with my other group. Instead of going to the homework, let's add an extra page and try an exam style question. No! Here we go. Here's my exam style question.
I had a question about the warm-up question.
Yeah.
I thought it asked us to find like the 8% range, like the small, like the top 8%.
Sorry, let me just read the question.
Find the range of weights of
Find the range of weights. Yeah, so really, you're right. We need to say that the cauliflower is X.
The 877 is the minimum for that range, but like
X is greater than 877 grams, I think would be. It's what you're meaning is the better answer. So what the question's asking.
I guess I tried to find a maximum by like doing like empirical to the top one, but
there is no maximum. There's not going to be many that are much more than 900 or so. You don't have a maximum end on this type of thing. But one other interesting thing I did here that's worth talking about is here at this point I'm saying it's greater than. What is the opposite of greater than? The opposite of greater than is less than or equal to. Isn't it? Why does it not matter with a normal distribution? It would matter a lot with binomial distribution, but with a normal distribution, it doesn't matter. Why is less than or equal to exactly the same as less than?
Because the value, that is R, is already excluded from the equation.
No, what it comes from is in the normal distribution, how many cauliflowers will be 877 grams? 8% will be more than 877. How many will be exactly 877?
Really small.
None, because it's continuous data. They'll be either side of that very finite point. If you could weigh it to the nearest picogram, they're going to be either side of that type of a point. We don't usually weigh with that degree of accuracy. If we're weighing to the nearest gram, then they would be. But with continuous data, it sort of lies in a continuous line, so nothing lies at any particular point. They all lie either side of a point. It's a weird concept. All right, so here's an exam style question. This is from last May. This is the actual question from the exam last May. So I've never done this question before. Let's have a go at this question again. So on a specific day, the speed of cars as they pass a camera is modeled by a normal distribution with a mean of 63.3. a speed of 75.7 is 2 standard deviations from the mean. Find the standard deviation of the cars. We'll do it together. So you guys have a go at that. Okay, so for part A, we could start off with 75.7 is equal to the mean plus 2 standard deviations, which is equal to 67.3 plus 2 times our standard deviation. Let's n solve this one because we don't like to do any math whatsoever. Algebra, n solve. We want 75.7 to equal 63.7 plus 2 times x. Solve for x. So we get 6.
Should be 6.
Did I type it in wrong? 0.7. Oh, I typed it 0.7, not 0.6, 0.3. 6.2. This gives us the standard deviation is 6.2. What's the units of the standard deviation? Kilometers per hour. If the mean is in kilometers per hour and the speeds are in kilometers per hour, the standard deviation is in the same unit. So this is in kilometers per hour. Okay. Speeding tickets are issued to all drivers traveling at a speed greater than 72 kilometers per hour. Find the probability that a random selected driver who passes the speed camera receives a speeding ticket. Let's have a go at this one. Keep it up a couple of minutes. Okay, one more minute.
I mean,
The
I tried to, I don't know, I just.
What part do you say?
Sure. Sorry, let me just get the answer. We should get an answer of 22.4%. All right, let's have a look. B. So we're told it's normally distributed, so we say that X is normally distributed with a mean of 67.3 and a variance of 6.2 squared. We want the probability that X is greater than 72. Pull up the calculator. Menu 552. So obviously this is standard normal distribution. We're not doing an inverse problem here. Our lower bound is 72. They're not going to be going more than 200. The mean is 67.3. The standard deviation is 6.2. And we get 0.224. So 22.4%. I like to answer as a decimal. 0.224. That's how that looks. Let's try C. So it is found that 82%, sorry, let me just copy down the mean. We've got the mean is equal to 67.3, 67.3, standard deviation is 6.2. All right. So it's found that 82% of cars on the road travel at a speed of p kilometers per hour, and 82% of cars on this road travel at a speed between p and q kilometers per hour. This interval includes cars traveling at 74 kilometers per hour. Show that the region of the normal distribution between p and q is not symmetrical about the mean. Try and start by sketch. Start by sketch the problem.
6.2, not 6.2.
Okay, let's just go back. I think we got the first question wrong here. So this one isn't 6.2, it's 4.2. So we've got 75.7 minus 67.3. Minus 67.3 divided by 2, 4.2. So the standard deviation is 4.2, which means we must have the wrong answer here as well. Let me just correct those answers.
It's 0.13 for A or B.
So this is 4.2. The variance is 4.2 squared. And this calculation should be a 4.2. We should get 0.132. I spotted that was wrong when I tried to do this question. It didn't come out right. It was symmetrical about the mean, but it won't be this time. So how can we see whether it's symmetrical about the mean? What I said to do, when you get to these harder type problem solving questions, start by sketching. Start by sketching. So we've got a normal distribution curve looking like this. This distance is 67.3. We're told that our interval that we're looking for includes this point here, 74. We're told that our interval is 82. So what we're doing here is our interval has to be between a couple of points, and it could look something like this. So it could look something like this. There's our interval. It's going to be a big wide interval. It wants to know, obviously if you move this yellow space up and down, it can move up and down. So this yellow space could be drawn like this. As long as it gets to 82, it could be drawn like this. It wants to know, is there enough space to draw it so it is symmetrical? Now if it's symmetrical around the mean, then there's enough space here to bring it down far enough. So that leads you to think, what you need to know is how big is this? What's the smallest value that area can have in order to still make 82% around the mean? So if this is, if the area includes this, and the smallest area it could make would be this area here, like this. So for it to be symmetrical, you can add bits either side of here like that, as long as you add the same amount. But you have to cover the symmetrical space. Those green bits could grow in small in order to make 82. So what we're looking for is there enough space between here and here to get 82%? Is there enough space here to get 82? That means there has to be enough space here to get 41. There has to be enough space here to get 41. Is there? Well, we can calculate that space. So if we take the probability that 67.3 is less than x is less than 74, this number has to be bigger than 41. Otherwise, there's not enough space to make this symmetrical about the mean. So we put this into our calculator, and what do we get? Put this into your calculator now, see what you get. we get 44.5%. This is equal to 44.5%. So there's no way that this can be symmetrical about the mean. We have to reason this. So this diagram would act as part of your reasoning. This would have to be, in order for it to be symmetrical around the mean, you have to have this. So twice this is going to be more than 82. There's not enough space to make this symmetrical around the mean. So to make this symmetrical around the mean, you could do it with a diagram again. So let's draw another diagram. So we know that for it to be symmetrical around the mean and still include 74, it has to go all the way down to 74 minus 67.3 times 2. 74 minus that value has to go all the way down to 60.6. Now this area is too big. This area is going to be that value times 2. 88.9%. This is 88.9. That's the smallest possible area that can be made to include 74 and still be symmetrical around the mean. And that's bigger than 82. So that's not possible. So you have to give your reasons. And you have to say 88.9% is bigger than, what did it say, 82%, which means it's not possible. That the region is symmetrical. Okay, that's it for today.